Hello everyone, welcome to RN tutorials. So now I am going to discuss about the frictional losses. So frictional losses means in the name itself, it is looking like the losses we will get due to the frictional resistance offered. So here in MFHM we are studying about the flow, that is the behavior of the fluids. So here we need to discuss about frictional losses in pipes. So whenever the flow of the fluid is taking place through a pipe, certain losses takes place due to the frictional resistance offered by the pipe. So here I want to assume a pipe. Okay, so through this pipe flow of the fluid is taking place, assume. Okay, so whenever the flow of the fluid takes place through this pipe, so according to the internal surface condition of this pipe, certain resistive force will be applied opposite to the direction of the flow. Okay, due to this resistance, again the velocity variation takes place for the flow of the fluid through the pipe. So the variation means the velocity may be reduced and again the flow rate may be reduced. So this reduction, the pressure also may be reduced due to the restriction offered by, that is the resistance offered by the internal surface of the pipe to the flow of the fluid. Okay, which causes the loss of energy or loss of head for the flow of the fluid, which is due to the resistance again offered by the internal surface. Okay, so that resistance can be offered by according to surface condition, means here if the surface is rough, it can apply more resistance, so that resistance we can assume as frictional resistance. Okay, due to this frictional resistance applied by the pipe to the flow of the fluid, we are facing a variation in the velocity. How the variation in velocity takes place means wherever the fluid particles in contact with the surface of the pipe, okay, for those fluid particles velocity will be zero, and again when you are coming towards the center of the pipe, okay, the velocity again becomes to velocity of the flow. Okay, so that means the velocity variation takes place from 0 to again the velocity of the flow for the pipe. So this velocity of flow again will be varying according to the internal resistance, that is the frictional resistance offered by the pipe. Okay, due to this velocity variation we will be facing the loss of energy. Okay, so that loss of energy is called as, we will be considering as frictional losses, because this loss of energy we are getting due to the frictional resistance offered by the pipe. Okay, so here, so to derive an expression for the loss of head, that is due to the friction, uh, william Froude william Froude is a scientist who conducted an experiment for the flow of the fluid through the pipe to observe certain variation in the properties of the fluid. Okay, now, and those properties can be proportional to the frictional resistance. Okay, now, so based upon the frictional resistance, what are the properties are weighing, those properties can be proportional to the frictional resistance. So like this he has given the statement. So the friction, he has stated that the frictional resistance, whatever the frictional resistance offered by the internal surface of the pipe can be proportional to whatever the velocity variation is taking place, which is v power 1. So n varies in between 1.5 to 2, and similarly same frictional resistance can be proportional to density of the fluid. So according to the density also, the frictional resistance can be improved or decreased. Okay, so when it is denser, the more resistance can be experienced by the liquid uh, that is applied by the internal surface of the pipe, and similarly it will be proportional to the area of surface in contact with the liquid. So based upon the surface condition only we are facing the frictional resistance. So that frictional resistance can be proportional to the area of surface in contact, that is the surface area of the pipe. Okay, na? So that frictional resistance can be proportional to internal surface of the pipe, and similarly it is independent of the pressure. Okay, it is independent, he has stated that it is independent of pressure. Okay, now that means the pressure value cannot affect the frictional resistance that is offered by the pipe, but due to the frictional resistance the pressure varies. Okay, but according to analysis of the frictional resistance, that is independent of the pressure. And here again we can say that this frictional resistance is dependent of surface condition. So based upon surface condition only, we are facing the frictional resistance. So this surface condition also causes the frictional resistance offered to the flow of the fluid. Okay, so these are the laws given by the William Ford for deriving an expression for the loss of head due to friction. Okay, so this is simple thing about the frictional losses. So the losses taking place due to the frictional resistance offered by the internal surface of the pipe to the flow of the fluid. Okay, so in the next video we will study about how to derive an expression for the loss of energy or loss of head due to the friction. Okay, I hope you understand this simple topic, and once again thanks for watching my video, and don't forget to subscribe to my channel. Thank you all.